So I'm just going to talk myself through it. But basically, you count the elements on both sides. So we got nitrogen and hydrogen on both sides. There are 2 nitrogens, 2 hydrogens on the left. And on the right side, you got 1 nitrogen and 3 hydrogens. Okay. So hopefully you guys got that for your initial counts. Now, if you guys notice, the nitrogens are not balanced. Which side should we add more nitrogens to? Yeah, the right side, because it has fewer. So we're going to add the entire molecule. Remember, this is like a recipe. You can't add new stuff. You can only add what's already there. So now you have 2 nitrogens, and you have 6 hydrogens. Okay. So now the nitrogens are balanced, and the hydrogens are not. Okay. So we're going to go on the left side now because it has fewer hydrogens, and we're going to add hydrogens until they balance out. So I'm going to add H2. Now I have 4, and then I add 1 more, and that's going to get me to 6. So that's going to be the balancing for that one. Okay, so the numbers that you would put in front, so you could either leave this blank or write a 1 because you only got 1 of these molecules. You have 1, 2, 3 H2 molecules, and you have 1, 2 NH3 molecules. Okay, so that's how the balancing is going to work. So hopefully not too bad. Any questions about the balancing? Guys chilling? Okay, so let's go into the new stuff. Okay. All right, so today we're going to be learning about something called stoic. The full name is stoichiometry. It's kind of a weird word. And you guys don't need to write this definition down, but basically we're going to be using conversions to determine how much product an amount of reactant can make and vice versa. Basically, if I give you a certain amount of chemicals, how much of another chemical can you make out of that amount? It's basically what it is. Okay, so there are 3 steps to doing stoic. This you're going to want to write down, okay? So when you have a stoic problem, basically most of the problems going forward, you're going to follow these 3 steps and you should be good. So the first one is balancing, which you guys should be familiar with. And you can always, paraphrase the steps. You guys don't need to write it word for word. So first step is balancing. The second step is you want to find the molar mass of whatever's involved, basically the important stuff. And I'll tell you guys how to distinguish the important from the non-important. So step 1 is balance. Step 2 is molar mass. And then step 3 is dimensional analysis. Another way to think of it is your fractions, your conversions, basically your math stuff. Okay. And so those are the 3 steps for stoichiometry. And we'll go over a practice problem now. Okay, so we're gonna take a look at number 2, the practice problem. Now, you guys don't need to write this equation. This is the one that we balanced for the warm-up. But when you guys get a chance, I want you guys to copy this big thingy, fraction thingy down, because this is what we'll be using to do our stoichiometry. Now, since it's our first day doing it, I'm giving you all the fractions for today. But slowly and slowly, I will take things away from you. So I'm going to get rid of first the stuff on the fractions, then I'll take away the fractions. And so you'll have to figure out how to set up these fractions on your own eventually. But for today, don't worry about that. I'm going to give you guys these for a couple of weeks. Okay. And make sure this is big enough on your paper for you to write numbers and stuff on it, because, yeah, we're going to be writing on the fractions. I'll give you guys another minute to copy that down. All right, you guys ready to get started? No? Who's ready to get started? Okay, I will wait a little bit longer then. Alrighty, guys. Let's get started. So, we already did step one, right? Step one was to balance the equation. So we did that during our warm-up. So hopefully you guys have it written down. Now, step two, we want to find the molar mass of the important chemicals, the involved compounds. So what that means is basically you're going to figure out what your starting number is and what you want to end up with. Basically, what we've been doing for the past couple assignments. Okay, so this was step one right here. And then for step two, we're going to figure out what the starting chemicals are, or the starting number is, and what you're looking for. God bless you. So if you take a look at this problem, it says 12 grams of N2 gas react with excess H2 gas. How many grams of NH3 gas will be produced? So just by looking at that, starting numbers should be pretty easy, right? What's the starting number for this problem? Yeah, 12 grams. So we're going to write down 12 grams. God bless you. Okay. But now we need to be a bit more specific than 12 grams. 12 grams of what chemical are we starting with? Yeah, nitrogen, N2. So we're going to write down our starting number as 12 grams of N2. Okay. So far, so good? Okay. All right, so that's what we start with. Our ending point is what we're looking for. So what are we looking for in this problem? Yeah, how many grams of NH3? Usually, what you're looking for is going to come after how many. So how many or, yeah. Okay, so we got our starting point and our ending point. And that's going to tell us what the important chemicals are. The important chemicals are N2 and NH3. Make sense? Okay, so now that we found the important chemicals, we are going to find their molar mass. Okay, so what we're going to do is we're going to go on the periodic table and find out the molar mass for N2 and NH3. So let's start with N2. I know it's been a long weekend, so we'll go over a quick refresher. So if we look at N2, it's made out of 2 nitrogens, right? So we go on the periodic table, we look at nitrogen. What's the molar mass of nitrogen? Yeah, 14.01. We can round that to 14. So the molar mass of nitrogen is 14. And so if there are 2 nitrogens, the molar mass is going to be 28. It'll be 28, and then it'll be grams per mole. Okay, easy peasy. All right, I am going to give you 45 seconds to find the molar mass of the other important chemical, NH3. So you can work with the person next to you, take a look at the periodic table, and I'll give you 45 seconds to find the molar mass of NH3. Hey, Ian, can you come here real quick? Sorry. I need to make a quick delivery. You see that box of headphones?
Yeah.
Can you take that to Mr. Edwards' class? Not this one.
Oh, the other one. Oh, yeah, the 5 by 5.
Yeah. Thank you. You're chilling. Just take the whole box.
Okay.
Yeah, that's fine. Thank you.
This box is what is it? 523.
523, yeah.
Oh, okay.
Just 2 doors long. Thanks. Alrighty, guys. So let's go over the molar mass of NH3. So hopefully you should have noticed 1 nitrogen, 3 hydrogens. Nitrogen is 14. And so there are 3 hydrogens, which are 1 each. So 14 plus 3 gives you 17. Okay, so NH3 should be 17 grams per mole. Yeah, you're going to want to write it down. Well, you don't have to. I'll see you next year. You love this class that much. I'm kidding. By who?
I wasn't even talking.
Dude, get out of this class. How I got 17? Yeah, NH3 is made out of 1 nitrogen, right? Nitrogen is 14 grams per mole. Hydrogen is 1, right? But then there are 3 of them, so 1 times 3 is 3. Dude, so rude, man. I answer your question like, okay, I'm done. Are you sure? You sure? You don't need me to show you how to add these? 14 plus 3. Okay, just making sure. Okay, so we did steps 1 and 2. Now we just need to do the last step and we will be all done. So the last step is the dimensional analysis or the math portion. And so to help you guys out, I have this neat little setup for you guys. Okay, it looks a little intimidating, but it's pretty easy to use. Okay, so this first blank is where we put our starting number. Okay, so we're gonna always put our starting number in the first blank. Okay, which is gonna be 12 grams, and then it's gonna be about N2. Okay, so 12 grams of N2. Okay, so far so good? All right, so let's look at the first fraction. We got to put some numbers in here. Now, if you guys take a look at this fraction, there are grams and moles in this fraction, right? It's been a long weekend, but does anyone remember if I have grams and moles on the same fraction, where do we get our numbers from? Yeah, periodic table, molar mass. Yeah. So the numbers for this fraction are going to come from the periodic table stuff you just added up. The technical term is molar mass. Okay, so we're talking about molar mass. Now, which chemical did we start off with? N2, so we're probably going to use the molar mass of N2 on the first fraction. Okay. Okay, so if we take a look at the molar mass of N2, it's 28, right? Now, 28 is next to grams, right? Where's grams on this fraction? Top or bottom? Bottom. So where should we put the 28? Yeah, bottom. So we're going to put 28 on the bottom. And then molar mass is the mass of 1 mole. So for molar mass fractions, we always put a 1 next to moles. And if you guys remember from last time, it's because if you have something on the top and bottom of a fraction, these can cancel each other out. So the grams and the grams will cancel each other out. All right. Any questions on that part? No one? Okay. So let's go to the next fraction. So if you notice, there are moles and moles on the same fraction, right? If there are moles and moles on the same fraction, where do we get the numbers from? Yeah, the chemical equation. Okay, so we're gonna get the numbers from the chemical equation. All right, now we need to figure out where to put the numbers, right? Now, before we can do that, we got to figure out which chemical we're talking about on the top and which one we're talking about on the bottom. So let's look at the previous fraction. We just said the grams will cancel out with the grams. So we have moles right here, right? Now we want to get rid of this moles. If this fraction is about N2, that means obviously this is talking about moles of N2, right? So if I want to get rid of moles of N2, where should I put it on this fraction? The top or the bottom? The bottom, yeah. So this bottom moles is going to be about N2. And we're trying to turn it into NH3, so we're going to put that on the top because that's what we're trying to get. Okay. Okay, so again, just to repeat myself, this fraction right here was about N2, so this is moles of N2. And since we want to get rid of N2, we put it on this fraction on the bottom. So that way, moles of N2 can cancel out with moles of N2, okay? Because we want to turn it to NH3. Okay. All right, so from here, pretty easy. We just look at the balanced equation. What number is in front of NH3? 2. So we're going to put a 2 right here. Okay, what number is in front of N2? 1. So we put a 1 right here. And so we're almost done. Alrighty, so last fraction now. So obviously this one is going to be about which chemical, NH3 or N2? Yeah, NH3, because all the N2 stuff has canceled out with each other, right? So now we only have NH3. So if I have grams and moles on the same fraction, where do we get the numbers from? Yeah, molar mass. So we're going to get the numbers for this one from the molar mass. And we are going to get the molar mass of NH3. Okay, because NH3 here, so we got to cancel out NH3 on the bottom right here. All right, so the molar mass of NH3 is 17. 17 is next to grams. So where should we put the 17 on this fraction? Top or bottom? Top, yeah. So it's flipped from this one right here. And then we put 1 mole on the bottom. And there you go, guys. That is the entire setup. Isn't it exciting? You're going to have to memorize this and do it without this little help thing. Because I respect you guys too much to let you guys use this forever. I respect your intelligence too much. No, I don't blame you. It's a lot of stuff. It's very early. Yeah. Yeah, it works because of remember the concept of the top canceling out with the bottom, right? So we start with grams of N2. So we need to cancel that out. So these cancel out top and bottom. Moles of N2 cancels out with this. This cancels out with that. And then all we're left with is what we're looking for, grams of NH3. So don't stress too much if you're just kind of filling in the blanks. As we use it more, it'll make more sense, especially once we do the lab and you see how it works in real life. It'll be more helpful. Oh yeah, we just gotta solve it out now. Okay, so let's do the math because I know you guys all love math. Okay, all right, so all the numbers on the top, what do we do with all the numbers on the top? Yeah, multiply. Yeah, the other one. And then all the numbers on the bottom, we are going to divide. Okay, so yeah, we got to solve it now. We're not done yet. I feel like I made chemistry a little too easy in the beginning for you guys. Now you guys want easy stuff. Okay, so let's punch in the numbers left to right, okay? So we start with the 12, so we're going to plug in a 12. If you go to the next fraction, there's a 1 on the top. If you do 12 times 1, it's still 12, right? So we can ignore the 1s for the multiplying and dividing. So what should we do with the 28 on the bottom? Divide. So 12 divided by 28. Let's go to the next fraction. What do we do with the 2? Yeah, multiply, so times 2. And then the last value is 17, so we're going to multiply by 17. And there you go. We get our final answer. Now, again, you guys don't need to, please do not write everything that comes out in the calculator. Just give me 2 or 3 numbers after the decimal, and you should be good. So if you get something around 14.57, that should be fine, okay? If you round to 14.6, I'm cool with it. If you give me 14.571, I'm cool with it. Just don't give me something like 15 or 14 flat. Then that would be incorrect. Okay. Did you have your hand up? Okay. All right, now we're not done because we need to write our units of measurements. Okay, so it's 14.57 what? Yeah, grams of NH3. All right, you guys good? It's a lot of stuff, but don't worry, we'll do another one for practice. Too bad. All right, so we are technically not done because you need to do one more thing. Yes. I told you it's multi-step. It's a lot of stuff, guys. Dude. Guys, don't blame me. I didn't make this stuff up. No, I didn't. You think I'm smart enough to come up with something like this?
Yeah.
You guys see me spill coffee on myself like every day. Okay, so the last thing we need to do is we need to write a quick sentence explaining what happened. And so I'll show you guys. You guys probably didn't know it was a math class either, but okay. So last step. This is how you're going to write the sentence describing what happened. You're going to say that 12 grams of N2. So whatever your starting number was, I know this is making you guys very excited, maybe anxious. Okay, 12 grams of N2. You're just going to write produces 14.57 grams of NH3. And then now you are done. That's it. Yeah, this is what you have to give me for your final answer. You can write the term produces. You can write makes. Oop. Fat fingers. Okay, it doesn't matter. As long as you could write to me the starting number makes whatever your final answer was. Okay. And now we are done. We're done. That's one problem. How much time did it take us to do that? Yeah, about 25 minutes. But it'll probably be faster when you guys aren't listening to me yap at you guys.
Yeah, sure.
I guarantee it. I appreciate that. It's because of the ethnicity. What's up? 17. This number right here. It's the molar mass of NH3. Yeah. I know there's a lot of stuff, so please ask me just so I can clarify. Okay, I am going to give you guys a chance to try this on your own now, but I will be very, very nice, and we will do the first problem on your assignment. That way we cut one thing out, and I give you a free answer, okay? All right, so I know, I'm such a kind soul. Merry Christmas, guys. Okay, so this is going to be your assignment. So you guys can do this on your assignment paper. I know, isn't this exciting, guys? It's like the happiest day of my life. Every time I teach Stoic at the beginning of the year, just hearing you guys groan and be sad. I see the light come out of your eyes.
He said, no, I'm good. Like,
all right. Anyway, so this is the first problem on your assignment. I'm going to give you guys 5 minutes to try it out with the person next to you. It's the exact same steps that we just did, obviously with different chemicals. But see if you guys can try it out. It's good to kind of struggle through this. That way it helps connect it better. So I'll give you guys 5 minutes to try it out. Work with the person next to you, and then we will go over the answer. And then, yeah, and I'll have you guys start on your assignment after this one. So go ahead and try number 1 from your assignment. Okay, guys, so let's go over this. And so again, if you guys notice, you guys have you guys have to do these problems on your own later for your assignment. There's 5 of them. So just make sure you're following along. If you have any questions, let me know. I know 5 questions. 5? Okay.
I'll take a 30-minute each.
Yeah. No, you can do it faster, I believe. Okay. So let's start with the balancing. I'm gonna just be frank with you guys. If the balancing is hard still, you're gonna want to review and practice balancing, okay? If you were absent, then that's obviously fair. You'll have some more time to work on it. But for those of you that were here, okay, but that's the balancing. Any questions on the balancing part? You guys good? Dude, I feel like I just overwhelmed you guys today. Okay. So let's go on to the next step. Next step is we need to figure out what's the important chemicals and find their molar mass. So what is our starting number for this problem? Yeah, 100 grams of HGO. So we are going to start this problem with this part right here. This is going to be our starting number. Okay, HGO. Okay, what are we looking for in this problem? What are we looking for? Yeah, how many grams of O2? Okay, so remember that whatever we're looking for is usually going to come after how many or what is, something like that. All right. You guys chilling? Okay. So we got our starting and our ending. All right, so if you're working on it on your own, please do it quietly so I can go over this. Okay. So our starting chemical is HGO, so let's find the molar mass of HGO. Okay. So HGO is made out of 1 Hg, so Hg is 200.59. So we'll pull up our calculator. So 200.59. And then O, oxygen, is going to be 16. So HGO is 200.59 plus 16. So 216.59. That's the molar mass of HGO. Yeah, because Hg from HGO is 200.59. O is 16. There's one of each, so we just add them together and we get 216.59 grams. Okay. So far, so good? Okay, so that's going to be the molar mass of HGO. Let's go to O2 now. So O2 is made out of 2 oxygens. So each oxygen is 16. So if there's 2 of them, the molar mass is 32. So that's all the steps that we do before we plug it into the fractions. I'll stop right there. Any questions on the balancing or the molar mass? Okay. So I know we're mixing all these together, but please don't freak out about it. It's just stuff that we've been doing. And it seems like you guys are pretty good with them individually. So it's just take it step by step. Okay. Are you guys sure you're okay to move on? Okay. All right, so let's go to the fractions now. So the first blank is going to be our starting number. So what is our starting number? Yeah, 100. So we're going to write 100. And more specifically, it's 100 grams of HGO. Okay, so we can specify that it's 100 grams of HGO. All right, you guys good? Okay, first fraction has grams and moles on it. So where do we get our numbers from? Molar mass, thank you. Yeah, no, you're good. It's just what's on your notes. Okay, same steps. Okay, so for the first fraction, we're going to be talking about the molar mass of the starting chemical, right? HGO. So we found the molar mass of HGO, and it was 216.59. So we're just going to write 216.59 grams in 1 mole. And we get that from this value right here, the molar mass of HGO. Okay. Okay, I'll pause right there. Are there any questions? Or is this making sense? If it does not make sense, please let me know. Okay. All right, let's move on. So this fraction is talking about HGO. So if I want to get rid of HGO, where should I put it on this fraction? Top or bottom? Bottom, right? Whatever we want to get rid of, we put on the bottom. Okay. All right, now the second fraction has moles and moles on it. And so we get the numbers from the chemical equation. So if you guys notice, the setup is almost exactly the same, or it is exactly the same as the previous problem. The only thing we're doing is we're changing up the numbers depending on what chemical we're talking about. Okay. All right, so we want to get rid of HGO, and we are looking for O2. So we're going to be talking about moles of O2 on the top. Okay. So if we look at HGO, the number in front of it is 2. So we got a 2 on the bottom. The number in front of O2 is blank, so that means it's 1. There we go. We got our setup. And for the last fraction, we're talking about O2. And then we're going to get the numbers from the molar mass of O2. Molar mass of O2 is 32 grams in 1 mole. So we're going to write 32 over 1. And there you go. That is your setup. Okay. So if you are able to get that or most of it, you are in good shape. Okay. So it's always going to be like this. You're always going to put your starting number here. Molar mass, chemical equation, molar mass. Okay. That process will never change. It'll always be like that. Okay, so let's plug it into our calculator and we will be all done. So our starting number is 100. We're going to divide by the number on the bottom, 216.59. We're going to divide by the 2 on the bottom and then multiply by 32. And our final answer will be 7.3. I'll round that up to 9. Something around there. 7.39 grams of oats. And there you go. That is your answer. Yeah. So let me go through the calculation part. So you start with 100. Okay, so we plug in 100 on the calculator. On the first fraction, we can ignore the 1 because 100 times 1 is 100. So we divide by 216.59 because it's on the bottom. If you go to the next fraction, there's a 2 on the bottom. So we got to divide that by 2 again. And then on the last fraction, there's a 32 on the top. So we multiply by 32. And that's how we get 7.39. If you put 7.38, 7.4, anything around there is fine. Okay, and then for the last part, for the sentence, all we just need to write is our starting number. The starting number is 100 grams of HGO. Produces 7.39 grams of O2. And there you go. That is everything. All right, so again, guys, I know it's a lot of stuff. We're putting together everything that we learned basically in Unit 2 together. But this is kind of gonna be the foundation of what we're gonna be doing going forward. So make sure you guys try it out, the assignment. If you have any questions or you want to check the answer key, please let me know. If you need me to walk through anything, I'm more than happy to help you guys. But I'm gonna give you guys the rest of the class period to work on the assignment, okay? All right, let me know if you have questions.